Okay, we're going to be talking about Lunei sword and shield animation, and I'm going to be focusing on more of the animation blend spaces and the head tracking and how that stuff was set up. So let's start just with a quick demo. I have a character here. I'm just going to equip some inventory on him. You can see he's got inventory that he can swap between, equipping and unequipping. We can also change character models. They can share those clothing using animation retargeting. Obviously, those clothing and armor has been modeled for each character, but then we are retargeting the skeleton so we can reuse the animation blueprint. But as for the clothing, each clothing would have to have been modeled for each individual character, and then we just equip them the correct mesh for the correct character in the background. So let's go to a sword and shield animation here. Oh, I pressed the H button hides the character. But then his animations won't play because the character's hidden. So let's swap to, for example, well, show some more animations. Our blend spaces here. We can crouch. We can walk as well. There's jumping, running, sprinting, jogging. And then for the attack animations, there's a bit of a build-up that you can do, and then once you've done that build-up, you can do an unstoppable attack. There's also like a shield bash that you can do. Let's swap to a different character here. I've unequipped my sword, and you'll see you lose mobility if you're not blocking and you get attacked. So the idea is to block, wait for an opening attack, block, wait for an opening attack. But some of these characters are responding a little bit too quickly after getting attacked, so it's going to make it a little bit difficult to attack them back. This is all still early days. And then what you can see here is we've got directional blocking, so you can actually control the character direction of the block using your mouse. You can see here, blocking up, blocking down. If I just quickly break the to show you what's actually happening in the background. Well, I'll show you how we did that setup now. Let's just go check out one more thing here. Let's drop ourselves in our little test area here. Let's swap to a different character, maybe her. And you'll see there's some head tracking going on here. Sometimes the characters will follow you with their head. There, that one's following you there. And they'll follow whoever is closest to them, depending on, and you can see that one's tracking me. And it's random, sometimes they'll do it, sometimes they won't. Your character will do it too. Like you can see, just looking at my character now, let's just get the helmet off. They're tracking someone there, that guy. And then they decide when to stop tracking whenever they feel like it. So it won't do that when you're in combat mode, because you don't want your character breaking their focus while they're in combat mode. Okay, so we've got the head tracking there. We've also we're controlling the spine, and you can see we've still got animation here. And this goes for all of the characters. You can control all of their spines. their blocking direction. Well, I haven't equipped any clothing. Let's so yeah, and that's all done using the same. It's using the same animation blueprint, so that's how we kind of managed to do that. I'll show how to do that now. And then you also have it while jumping. There's a little bit of jitter at the moment. It's still very early days. Here's some fog settling in. We've got weather effects as well. There's a day-night cycle and all sorts of stuff. Wow. It's a really thick fog. It should dissipate any moment. But that's not what I wanted to show now. Let's go take a look at the animation blueprint. We'll start with the animation graph. So what we've done here is we've got a locomotion cache. This is just a cache of the last transformations of all the skeleton that we can reuse later on in the animation update. And it will cache whatever came from this locomotion state, finite state machine that we've got here. So this would control, if you just look at the character here, this would control our character. So we could increase the speed, he'll start running. If we specify in air, he'll do a jump. We can swap between different animation sets. So there's, I think, 2 different sets, and you'll see them transitioning here between the 2. It's just different animation sets for the same thing. Also, like I said, there's jogging and running. So there's like a bit of a jog, and obviously walking. You can see there's a different one. If we swap to, there's a little bit of a different walk. Then obviously there's crouching. And with crouching there are 2 sets as well. He's got one set like that and the other like that, and you can transition between the 2. Direction and yaw input actually are used for something else. Let's take a look at the aim, how the aim works. So if I specify an aim rotation alpha here, and I put this at 1, this is my spine. See, my spine is doing funky things. What I could do is now I should be able to play with this. Let's see, with these rotation values here. So typically what we would do is we would actually use this rotation here to control the block. So let's go into, where's our block? Don't specify block here. It's interesting. So let's go into sword and shield mode. Come back to this. So now it's transitioned. So there's unarmed and there's the sword and shield locomotion set, and you'll see it's just, this is just a blend space, which I'll show in a second. But now, so these guys, there's a different set of animations here for walking and running again, but it's only one set. You can't crouch while you're in combat mode. And then here, this is where direction comes in. So with direction, you can actually control the direction of the animation blend space, but I'll show that in the blend space itself. It's more clearly there. So the idea with this would be, if you were blocking, actually I'm checking I think it's checking the blocking directly on the character, and I'm not populating it to the animation instance. So let's continue on with demoing the So this is what would happen if you go into block mode. You'd be able to control the spine. And let's go back to unarmed. Now, if we set head aim to full, and we just bring this guy, I think he needs to be, is it 90? So he needs to be about there. Then what you're able to do is you should be able to influence the head. Now he's got a lot of head bob here, so let's get him to stand still. Let's go into, it's a bit clearer, easier to see if his head isn't bobbing all over the place. But this is what we do to control the gaze. I'll show you how we set that up. This, when used in combination with all his other locomotion state, it gives a cool effect. So the last pose here would get cached into the locomotion cache. Then we have we reuse this cache for our full body montage blends, meaning any montages that require full body blends, full body upper and lower body animations like sword attacks and things like that would play out, and it would update, and the pose would get cached to this loco cache definition. So it goes from locomotion to loco cache. That gets used for full body blend, and then it goes to loco cache definition. Now these ones are then used 2 times. One for upper body, so we use the loco cache def, play the upper body, blend the upper body slot. We're defining spine here, so we're using a layered blend per bone. So we're blending between whatever was in the loco cache definition versus what's playing now in the upper body slot, where previously we were using the default slot. So this would be cool for things like blocking, attacking, and things like that on upper body, not full body montages. That then goes to loco cache 2. Then the next thing we do is we use the lower body, anything playing in the lower body animation slot or group. From the loco cache 2, that will get layered blend per bone, where we're specifying left up leg and left up leg and right up leg. And the reason we do that is because our pelvis is actually the root, and we didn't put in a root bone and make the pelvis part of the lower spine like we should have. So there's a bit of work that still needs to happen there. Once that's done, this is where the cool stuff happens, where we transition between, not really transition, where we do the aiming and rotation, the aiming stuff. So first thing we do is we take the output from the last lower body blend, keeping in mind this contains everything now, so it will contain the I just want to reposition this again. It will contain the pose from the locomotion, the last pose from the locomotion, whatever we're playing in the default slot, mixed with whatever was playing in the upper body, mixed with whatever was playing in the lower body. And you see we specify blend weight to 1 for both of these cases. So we want to take anything that's playing in upper body or anything that's playing in lower body. Then we take this, we call this local to component. So we're converting the pose from local space to component space. And then we're calling this transform modify bone. And what this does is it gives you control in the animation blueprint to control any spine, any transformation matrix, bone, skeletal bone at runtime. So we're specifying a blend alpha here. This blend alpha will be either 1 or 0, because when you're blocking, it actually snaps. So you get the ability to control the character block direction along the right axis. And then this will specify what that value must be, what the rotation value must be. The output of this will then go to the next step. Well, let's look at the settings here that I'm using. Rotation, it says replace existing, and it's in component space. Then it goes on to the next. This is the head aim rotation. It's got a head aim rotation alpha, and then it also specifies which bone, which is obviously the neck bone here, and we're also using component space. And then finally, when it's done, we go back from component space to local space, the pose, and then we output that to the final animation pose. That's the gist of it. Then in the actual update, we do the usual stuff where you need to set your velocity, your speed, are you crouching. We can determine which locomotion set must play depending on what the character wants. We're using a few other variables here, like we're calculating some direction. Instead of using, we're calculating direction based on the velocity, our current velocity, and we're not using active forward here. And then we've got a couple other variables here. Now this is the stuff where it starts getting interesting. Fine aim rotation. So this would be for I think blocking. So if the character is blocking, we snap the aim rotation alpha to 1. And then we use the follow camera and the character transform. We get the forward vector of the follow camera, and then we do an inverse transform direction using the transform of the character. So what we're doing is we're bringing the camera forward. We're transforming the camera forward by the inverse of this actor transform, and what that does is I think it should put it in the same space then as the character. So from the camera to the character. Because what we want to do is we want the camera to influence the character rotation. Then we're creating a rotation from X vector here. We're doing our little offset here. We need to offset because the rotation values aren't going to be the same for the camera and the character. So we need to do a little bit of tweaking here. And then we simply set the aim rotation. The head rotation works very, very similar. And there's just a couple of rules that govern when this can happen. It's based off mustn't be crouched, no other montage must be playing, you must have something to focus on, like another character, and must be unarmed. And if all of those values are set, we simply set a boolean here to say, okay, you should be head aiming. Then we do the same thing again here with the inverse transform. In this case, we're using the focal point world space direction. Now this actually gets set in the character C++. So focal point world space direction, and that is just a world space direction to the focal point, and it's really not that difficult to figure out. And then we create a rotation from X vector again, do our little funky offsets. We do some clamping because we don't want the next neck to break. I think we do clamping here as well. We don't do any clamping here. Oh, that's right, because the camera is actually getting clamped, so you can't rotate the camera in any case in further than a certain amount up or down. But here for the neck, we have to clamp it, otherwise you'll break the neck. It's just going to look bad. Make the rotator set the head aim rotation, and then we actually still need to set the alpha, and that happens here in update head animation. So what we're doing here, based on if this head aim is true or false, we just linearly interpolate over a period of time to either 1 or 0. So the head doesn't snap, it smoothly interpolates to where it's trying to look. So, but for the blocking, we actually want that to snap. We want the block to snap immediately. And what I mean by that is, if you, I just hit compile. If you, for example, if you look down, with your mouse and you hit block, it must immediately go there. I don't want it to slowly learn. If you look up and block, you must immediately block in the up, you know, looking up. That's what that is for. Shows here I made a change. And then what else? The locomotion state. In a finite state machine. These transitions here are, it's just all, you know, based on variables. So if you're going to go from walk to crouching, crouch must become true, but you've got two sets of crouch, so we always go to this one, and then this one will transition to the second set if need be, and then it can transition back to there on false, or from here to back if crouch is false. Same with the walk run state. It will always transition back here and only transition to walk run 2 if that value is set. The locomotion set is 2. That makes it nice. You don't have to do all transitions everywhere to all the states. You just always go back to a single state that controls which state you can go to from there if you have different sets of animations for a particular state. And then there's the jumping. We've got two. We've got one for when you're in unarmed, and then one for when you're got a sword and shield equipped. And that's it. That's what I wanted to show for this video. And you can also, yeah, you can mix and match clothing as well. So you gotta try and keep the clothing at some level. You'll see it's smashing through at times. That's going to be unavoidable. But you need to have some rules in place to try and minimize that. So the turning here, the turning animation isn't great. I'm not really crazy about it. This is where the blending comes in. So while I'm blocking, upper body is playing one thing and the lower body is doing something else. I didn't actually show that. But it's kind of straightforward. So if you have an animation montage, you can specify which slot it needs to play in. So for example, let's go look at the block. For block, we're saying we want to take whatever this animation provides, and we just want to play it on the upper body slot. And then for example, a sword slash attack would be upper body as well. And then we have something like, those are just different impacts. For example, this one here is a full body, so this one will go to the default slot. So because we require the feet to do something specific here. And that's where this upper and lower body blending come into play, and how you can blend upper and lower body. Cool. Thanks for watching.